Hello, ladies and gentlemen, Root Beer here, and I hope you're all doing well. We're going to finish off the 2009 Cayley contest in this video. That'll be question number 25, so if you haven't already, pause the video, give it a try, but let's take a look here. Okay, so unit squares are arranged to form a rectangular grid that is m units wide and n units tall, where m and n are positive integers, and 2n is less than m is less than 3n. So immediately I can see n is less than m. It's far wider than it is high. Not a whole lot else I can say from there, but I do know it's wider than it is high. Okay. And I'm just going off the picture. Maybe some sort of reflection needs to be happening because it looks like the main diagonal is highlighted in some way. The region below one of the diagonals of the rectangle is shaded as shown. For certain pairs m and n, there is a unit square in the grid that is not completely shaded, but whose shaded area is greater than 0.999. Okay, so it's... Alright. The smallest possible value of mn for which this is true satisfies... Okay, lots of different non-overlapping possibilities. Interesting. And they're talking about mn. Alright. So, what to do? Well, the first thing I'm noticing here is there's symmetry. If I take this upside down triangle and rotate it, it's going to match up exactly with this triangle. What does this mean? Well, I don't actually need to specifically be looking for a unit square that's not completely shaded, but whose shaded area is greater than 0.99. I can look for a unit square who's not completely shaded and whose shaded area is less than 1,000th as well, right? Because if I've got a shaded triangle here, there correspondingly is an unshaded white area up here in this square, and by symmetry they're going to be the same area. So we just need sort of a square who is split in some way, maybe a triangle, or I guess there are other possibilities we could have here, but we sort of need the ratio in this area and this area to be greater than 999 to 1. That sort of a thing. Okay. So that's okay. I'm tempted to possibly put some coordinates on here. Go from 0, 0 all the way up to mn. Because you'll notice as we, go one square, two squares, three squares, we could get a slope of a line pass through the origin, so it wouldn't be that bad. It would have y equals n over mx, and there would be no b because it passes through the origin. Okay. And maybe we can get intersection points in terms of how many units we go over k, and then calculate some areas there. It's tempting. So, now we're wider than we are tall, so if I were to, say, calculate the slope of this line, it's actually quite shallow. What do we got? 2n less than m less than 3n. And that divided by n, 2 is less than... That doesn't make... Oh, wait, no, the slope of our line is n over m. So if we reciprocal both sides... Remember, doing a reciprocal changes the sign of the inequality, just like multiplying by a negative number changes the sign of an inequality. So the slope is somewhere between 1/3 and 1/2. Does this help me at all? Well, if I'm crossing through a square, I will never go from the bottom to somewhere on the top. I will never have a height of 1 because that's if 1 is the rise, then the run would have to be, I don't know, call it x, and 1 over x has to be less than a half, but x is less than 1. So we'd have, so here x is less than 1, but if 1 over x is less than a half, being the slope, then we'd have 2 is less than x, and something about those two statements should seem kind of wrong. So we'll never go all the way up through a square. What could we have? Well, let's just brainstorm some ideas. I know I could go through... I can go through a corner, because that's how we start everything off. We go through a corner, but we certainly don't go high enough to reach this side. Okay. So if we enter in through a corner, we're going to have to come out this side here. And this height here actually will be n over m times the distance we've gone, which is 1. And so if that were our shaded area, okay, or if it were flipped over and that were our unshaded area. Remember what I said about symmetry at the start. We just need to make sure that when the line divides it, one of the areas is less than a 1,000th. That's what we're looking for. So the area here is 1/2 base times height, and so this will be n over 2m. But again, n over m is less than a half, so this will be less than a quarter. Well, that's allowed. No. Silly me. This will be bigger than a sixth. I'm using the other inequality. Bigger than a sixth, and so it can't be less than 1,000th, this tiny little triangle here. Not if we enter in from a vertex, but we could enter in, we could go here and just not go high enough. So we could enter in from the bottom and slowly creep high enough there. So that one would be fine. Is there anything else we could have happen? So we can enter in from a corner, this bottom side, or this left side, as we're doing our diagonal. Now, if I enter in from the bottom, I have to leave by the right-hand side, because as I already mentioned, I can't leave through the top. If I enter in from the side, I suppose I could leave through the top, but that's just going to be a symmetry of this case right here, so no point in considering it. And if I enter in from the left, I suppose maybe I enter in sort of low enough that I exit through the right as well, and so I'll get split up into quadrilaterals. Now, there's a run of 1 there as well, so I don't think that's going to help us. So if I enter in from the side and I leave the other side, let's just get some colors here. So I don't know which side would be shaded or not, but I know both sides will contain these blue triangles. They're both going to be congruent triangles, but again, we're going to have a run of 1 and a rise of n over m, and so this triangle here, and so this triangle up here as well, is going to have an area greater than a sixth. So that's out. So the only way we can get 1,000 is if we enter on the bottom and leave on the right, or conversely, although I'm not going to do this case, enter in from the left and leave through the top. Those are the only ones that can make this sort of tiny enough triangle that might do the trick. I'm pretty sure that's the only possibility. Yeah. Enter here, leave here. That's allowed. Enter here, leave here. That's allowed. Enter by... Well, I suppose we could have enter in on the left and leave by a corner. That's allowed, but again, that's symmetry of entering in through a vertex. So, yeah. Can't go vertex to vertex because that's going to have a height of 1. That's not allowed. And again, we can go here to vertex. That's a height of 1. That's not allowed. Here to here, that's about it. Okay, so it really sort of has to be this triangle. Yeah, it's going to have to be this triangle. Okay, so I just needed this shaded triangle to be less than 1,000, because clearly it's going to be the small part. So, well, if I call this distance x, and I really have no idea what this x would be, this will be n over mx. And that has an area of 1/2 x n over mx. So this will be n over 2m x squared. And I want this to be less than 1,000. So, I'm not seeing a way to get mn in here at all. And, so x squared. No, let's say I know n over m is less than 1/2. So n over 2m has got to be less than 1/4. So n over 2m x squared has got to be less than 1 over 1/4 x squared. So x squared, if I want this to be less than 1,000, I should make 1/4 x squared less than or equal to 1,000th. Oh, but we also have, this guy's bigger than 1/3. So this is bigger than 1/6, so I might need both inequalities here. Not entirely sure. But if I bring the 4 over to the other side, this means x squared has to be less than 1 over 250. And that's going to be 1 over 25, 1 over 10. So that's going to be 1/5, 1 over root 10, or 1 over 5 root 10. So x has to be less than 1 over 5 root 10. Okay. So I'll grant you that. But does that ever happen? So I need I need my giant grid of rectangles to be wide enough and the slope shallow enough that I could get a little x here and a little something up. Yeah. So I just need x here to be less than 1 over 5 root 10. Now, this x distance, I think I can calculate it for, because we're inside this big rectangle. Big rectangular grid. And I'm going over. And now that I know which case I'm in, that is to say, we are definitely going up through something and heading over. What do we want to have happen? So the line that we go through would be equal to y equals k for some value. And remember, our line that I mentioned is y equals n over mx plus 0, because 0 is the intercept that we go through. We've got mn here. So if I intercept the k, the line y equals k, I can calculate this point here, and I can ask, what's it sort of closest to? Or it's got to be if I round it up. Okay. Now you might say, well, how do you know something like This one up here won't work. Okay. Well, if it did, there's going to, by symmetry, be another one down here. So I can always just focus on the, okay, y equals k, and what's the difference between this and the next biggest integer. Although I suppose I could do intersect x equals k and the y value and ask about... No, I think I'm good the way I am. So, okay. So if y equals k and y equals n over mx intersect, then k is n over mx, and that'll be mk over n equals x. And I want this, when I round it up, to be within, so the next biggest integer minus this value has to be less than 1 over 5 root 10. This is the equation I need to have satisfied. Okay, that's weird. And I still don't have an NM anywhere in here. I still don't have NM. But, okay. I know that 2n less than m less than 3n. And so 2 is less than m over n less than 3. So mk over n is going to be less than 3. No, that's not helpful. Because that's, I mean, the bigger k gets, the wider the range of possibilities here. I was making good progress. I'm wondering if this is... whether or not maybe I missed a case. I don't think I missed a case. I think I was pretty thorough in my how does the line go through these unit squares. But now it's the... Now it's about passing through. And it's this pesky greatest integer. By the way, if you haven't seen this before, for example, it's called the ceiling function. The ceiling of pi is 4, because that's the next integer bigger than or equal to. So the ceiling of 3 is 3, because 3 is the next integer bigger than or equal to. So essentially all I'm doing is rounding up. Forcibly rounding up. But... darn it, I don't like the ceiling function I've got there, and I don't like the fact that an m times n still hasn't appeared. I'm not happy about that. Okay. So, just trying to think. Well, here's what I'm going to do. I'm going to grab my calculator. 1 over 5 root 10 is about 0.0632. So that's a very, very small room for error. Does this help me? Not entirely. But I feel like, okay. If I do something like this, 1 over 5 root 10, and I add mk over n, if I multiply through by n, can I get something useful? Because having that fraction there, if I get rid of some of those fractions, that might be nice and useful. No, I genuinely think the ceiling function is not a good way to go. There's just too much unknown. I don't know this k, I don't know the m or the n. I don't even really have a good relationship with the m and the n's. I can do more inequalities here, but I think the fact that I still don't have a way to get mn out of this means maybe go back and look for something else. Now, I was happy when I had realized that it's got to be a case like this. Or a case like this. Okay? And because of symmetry, I can pick whichever one I want. I picked this one down here. Now, if I don't like that ceiling function, perhaps if I gave, so we'll call this line y equals k, what if I called this line x equals L? Yes, that's introducing a new variable, but it is getting rid of that absolute value. Or not absolute, I don't know why I keep saying absolute value. Ceiling function. Okay? Because in this case, I mean, I'm really just trading here. And is it just a trade, or do we get... And I think the main advantage of doing something like this is I can... If we're still talking about coordinates, I can talk about these coordinates. And I can... talk about... Yeah, I can definitely talk about those coordinates, and I think I just calculate the triangle. I'll have a k and an L in there. Is that going to be too many variables? Maybe I can get some relationship between k and L, or some approximate relationship. What would these coordinates be? So it'll be y equals k, and we'll get mk over n. And then the L, I put in L, and I get n L over m. Okay. I lose sort of my... Oh, rise over run. Rise over run. Rise over run. K... Let's say NL over M minus K over L minus MK over N. Multiply top and bottom by Mn, which is something I'm looking for, and I'll get NL minus MK over ML minus NK. And I know this has got to be equal to the slope of my line, N over M. And then I'll get MNL minus M squared K is equal to MNL minus N squared K. So we're going to have N squared minus M squared K equals to 0. Well, I can't have... So what would that do? That would be N plus M n minus m k have to be equal to 0. I feel like something's wrong. Because n and m can't be the same. N plus m is definitely not going to be 0, and k shouldn't be 0 either. So did I screw up? Oh, yes, of course I did. This is m over n, so I'll get n squared L over m minus nk has got to be ml minus m squared k over n multiplied by mn, and this is looking not particularly fun. Okay. There's too many variables. Although maybe we can go for the triangle again. I mean, yes, I used the difference in the coordinates to try and get equal to m over n. Although, in retrospect, that shouldn't have been helpful anyway, because we used the n and m to figure out parts of the coordinates here. But I can say that I want less than or equal to 1,000. So what is it? 1/2 base times height. So L mk over n, nl over m minus k. Yeah, that'll definitely be the height, and that'll definitely be the... Oh, I suppose it's got to be... Oh, no, it is L. Okay, so those will have to be positive values. This will be true, and I can multiply through by mn, and I'll be left with an mn on one side. So I'll get... well, first let's multiply by 1/2, so... I'm also simplifying the fractions as I go. Multiply by 1/2, so we'll get 1 over... Or multiply by 2 on both sides. We get 1 over 500. And I can multiply through by mn. And most of the answers were around 500, so this is not looking so bad. NL minus MK. And then, oh gosh, what was the other one? NL minus MK again. Ooh, I like that. And that's got to be less than MN over 500. That's NL minus MK squared has got to be less than MN over 500. Okay. So it's nice and neat and it's pretty, but does it help me at all? I don't think I want to expand the square. I want to say, okay, there's got to be a square less than or equal to, so we'll say, 500. Five times 100. Now we'll just say 500. Okay, now, the smallest possible square I could have other than 0, and I'd only get 0 if NL were equal to MK, that is to say, NL over M was equal to K, and that's not going to be allowed because then I'd be entering in... I'd be hitting this L, and then I'd be leaving at this K. No, that's allowed. Wait, what? This shouldn't be allowed for some reason. Okay, because if it was, then really any M and N would work. Oh, right, because if that were the case, then we'd be just at this vertex. Right, because then NL over M would be the same as LK. And so you would just be a corner. You'd just nick the corner of this whole thing, and that's not what we want. So I can't have 0 here. What's the next smallest? I could have 1. So if NL minus MK, if that were equal to 1, then I'd have 500 has to be less than or equal to MN. But of course, for this to be true, I would need the GCD of M and N to be equal to 1. Now, it sort of has to be true, right? It has to be true because the next possibility would be, something like this is 2, but then 500 times 4 is going to be 2,000, and that's got to be less than or equal to Mn. But if I look at my possibilities, we're definitely not at 2,000. Now, I'm pretty sure... Oh, I haven't necessarily ruled out A yet, have I? Because it could actually be equal to 500. So I need the GCD of M and N to be equal to 1. Why is that? Well, if GCD of A and B is equal to D, then you can find AC plus... I've already used D. I can find X and Y integers so that AX plus BY is equal to D. And so that's a nice property of being the greatest common denominator. And if I can find X and Y so that AX plus BY is equal to some number, then that number is got to be a multiple of the GCD of A and B. So if you're down to 1, well, it's going to have to be equal to 1. Because the GCD needs to divide A, B, and this 1. Well, only 1 divides 1, really. Okay, so that's, in case you didn't know that about the GCD, we've got that going on there. Okay, so I think this might now just be some casework. I need M and N that have a GCD of 1, that is to say they are relatively prime, which is the fancy term for GCD. So relatively prime. The fancy term for GCD of M and N being equal to 1. But we can't forget 2n has to be less than m has to be less than 3n. Can this happen? Well, suppose there's not that many cases. I could just try everything up to 520. Is there a way to simplify some of this? Well, 4n squared is going to have to be less than 2mn. That's not especially helpful, but 3mn has got to be less than 9n squared, and so that's got to be greater than 1,500. Nah, I don't know. I don't think that's particularly useful. So 500. Can I find 2 relatively prime things? Well, 500 is 5 to the power of 3 times 2 to the power 2. So I'd have to split them up into 4 and 125. And 2 times 3 times 4 is 12, and 12 is not bigger than 125, so that's right out. 501, let's prime factor 501. I'm not entirely convinced this is the fastest way to go about this, but I currently am at a loss for a better way. So it looks like this is 3 times 167. Okay. Oh, you know what might help? If mn is equal to some value, well, we've already used k. Let's call it p. I don't know. And I know n is less than m. That was one of the first things I said. And that means n is less than root p is less than m. And so 2n is less than 2 root p. Now, I don't know where m fits in all this, but I also know that m is less than 3n. Less than 3 root p. And so mn being equal to p, m being less than 3 root p, I'm not seeing anything that particularly helps here. Rats. Well, hold on. Let's just say something to the effect of, if m has to be less than 3 root p. Yes, by the way, I know that I could just do 501, 502, but for all I know, the answer is going to take all the way up to something like 518. So I'm trying to do this in a smarter way. But on a contest, if time crunches hit, then okay, they hit, and you've got to take your best guess or something like that. I know for a fact the answer is not A. That helps a little bit, because I just ruled out 500, but what if I were to say 501? What's the square root of 501? 22.3 something. So n and m, they've got to have 22.3 something in between them. And I still feel like there's something I could be doing. So (2n) less than m less than 3n. Multiply through by m on both sides, so 2mn less than m squared less than 3mn. Then I can also say that 2n squared is less than mn. So 4n squared is less than 2mn less than m squared. Yeah, that's nothing new. Rats. I'm really trying to avoid prime factorizing 20 numbers, but I guess if I've got to, I've got to. So we'll, 501 to 505. So this is what, 5 times 101. Those are the only that's the only prime factorization you can have. So n's got to be 5, m has got to be 101. So that's out. This is 7 times 2 to the 3 times 3 to the 2. I feel like there's potential there. This is 3 times 167. Again, semi-prime, so that's really the only way I can do this. It's just, really wish there were a slicker way to do this. If there is, I'm not seeing it, which, you know, is a shame, but so be it. I don't like a question where I've got to do 20-something cases. 503 is not a multiple of 7, not a multiple of 11, not a multiple of 13. How about 17? Nope. How about 19? I'd show you me doing this, but this is actually just boring calculator work. So I'm pretty sure 503 is prime, so that's out. How about 502? 251 times 2. 251 not a multiple of 3, but it's less than 256, so I only have to check primes up to 16, so primes up to 13. Not a multiple of 13, not a multiple of 11, not a multiple of 7, not a multiple of 5. So this is it. It's semi-prime, so that's also not going to work. Now, in terms of the 7, 2 cubed, 3 squared, is there a good way to deal with this? Well, I could try something like, well, you know what? How about we just list out the possible n's and the corresponding m's, and the 2n and the 3n. 1, 2, and so on it's not going to work out. M has to be less than 3 root p, which I did observe. So square root of 504 is probably around 22 again. Yeah, 22. So M has to be less than 66. So 66. I could have 63, which is 7 times 9. And then I'd get n is 8, but then that's 1632. That's not enough. Okay. So 2n less than m less than 3n. I did already make this comment, but this sort of helps a little bit to narrow down n. So n's got to be less than or equal to my number, 504, over 2 and square rooted. So 504 over 2 is 252, and what's the square root of 252? So n can be at most 15, and similarly, it's also got to be greater than or equal to 504 over 3, which in this case is 168, and if I square root 168, I get 12. So it's got to be between 12 and 15. It's got to be bigger than 12. So 13. 13's not a factor here. 15's not a factor. It's got to be 14. 14 now, does that work? 504 divided by 14. 36. And that's the only possibility, but these are not relatively prime. It's got a GCD of 2. Gosh darn it. Okay, so that rules out B, and I'm still unhappy with how much casework I'm having to do here. 506, 507, 508, 509, 510. Pick whichever one I want to start with. I don't know, 507 is a multiple of 3. So this is 13 squared times 3. So either all the 13s are together. Well, actually, all the 13s have to be together, and so it's either 3 and 169 or 1 and 507. This is not going to work. Let's try something new. 506 divided by 3 is 168, and I square root it. That's going to be 12. Nah. This is just 2 times 253. 253 strikes me as a prime. So go up to 15. So 253 divided by... Oh, no, it's a multiple of 11. So this is 2 times 11 times 23. I could have 22 and 23. But then 2 times 22 is 44, and that's too big. How about 11 and 46? Now it's the opposite problem. The M is too big. Yeah, that one's out. Okay, how about 508? Divide by 4, can't I? So this is 2 squared times 127. I know that's a prime. It's a Mersenne prime. Is it a Mersenne prime? Yeah, it's a Mersenne prime. And that's still not going to work. How about 509? Not a multiple of 3. 509 divided by 19? Nope. How about divided by 17? Nope. Divided by 13? Shouldn't, because we just had a multiple of 13. Shouldn't work for 11, just had a multiple of 11. How about 7? Not a multiple of 7. Not a multiple of 5, not a multiple of 3, not a multiple... It's prime. Alright, 510, you're my last hope, and then it's down to D or E. So, 2 and a 5, and then 51. We get 3 times 17. Well, at least it's a little more varied. I could have 10 and 51. That's not going to do the trick. Well, I'll tell you what. I can use my 510 divided by 3 square rooted. So I've got to be bigger than 13. And 510 divided by 2 square rooted. I got to be less than 15. Less than or equal to 15. So I could have 15 and 34. That's those are relatively prime. And 30 is less than 34 is less than 45. So this works, and the answer is C. Okay, so at long last we're done. That took a lot longer than I want a Cayley 25 to take, to be honest. I think it was a bit obnoxious at the end, and I think I'm going to go read their solutions and see if there's a better way to do this other than the casework I had at the end. But I would say it was fairly smooth and straightforward when I was looking at the geometry of, okay, how can the line intersect the squares? I liked that. That was good. I got a little hung up when I started using the ceiling function, but if I kept it with coordinates with that K and the L, it turns out it didn't get too complicated. And then it just became casework. And, you know, it didn't keep me all the way till D or something like that, but it's obnoxious. There's got to be a better way to have done this at the end. I suppose, if I'd been smarter about this, I suppose something I could have made a comment about, I suppose we could have said, you know, so it's 496 to 520. MN's got to be somewhere in here, right? So maybe this is a slighter shortcut. But remember that if I divided by 3 and so the n's got to be somewhere in here. Right? And so 520 divided by 2 is 260, and the square root of 260 is 16 point something. So n's got to be less than 16, and it's got to be greater than or equal to 13. So I suppose if I had limited myself to multiples of 13, 14, 15, and 16, that might have helped. Now, how could this have narrowed things down? So what's the nearest multiple of 13 to 496? So 38 times 13 is 494. So if I add 13, I get 507. If I add 13 again, I get 520. Okay, so those are certainly possibilities. How about 14? Well, I can get 504 is a multiple of 14. And then if I add 14 on again, I'll get 518. Again, a possibility. How about multiples of 15? Well, we saw 510 is a multiple of 15. And 495, no, just 510 for the 15s. And in terms of multiples of 16, 496 is a multiple of 16. And if I add 16 to that, 512 is a multiple of 16. So if I'd been a little smarter, maybe I could have only had to do these cases here. I think that would have been better. And I sort of already know what my n has got to be in each of these cases. There is no overlap. So it's, 507 is n is 13, and then what's left over? 39. Well, those aren't relatively prime, so you've got a problem there. 520, that'd be 13 times 40. Also, you should probably go smallest to largest here, really. Now, I also learned that mn has to be at least 500, so that would have thrown the 496 out of whack. So I would have checked 504, 507, and then 510. And so then it would have only been 3 numbers to check, and I would have gotten my final answer. That's not as bad, but it still took me a little while to figure out those formulas. Anyway, that does it for the 2009 Cayley. Hopefully you had a better way to do, or at least a shorter way to do it, for question number 25. Overall, I thought it was an okay contest. My next Cayley will be the 2010, but that won't be for a while. Up next will be the Galois from 2009, so still grade 10 level, but written solutions. So good to practice, especially if someday you want to write the Euclid. But I'll leave it to you whether or not you want to move on and take a look at a Galois video, or just wait for the next Cayley, or check out some of my past Cayleys. That's fine too. Whatever you end up doing, I hope you have a wonderful day, and I hope you continue to try these math contests. I think they're wonderful, and I know a bunch of you out there think that as well. Have a wonderful day.